Hey, welcome. We're going to talk about how to detect STRRAT, which is a malware family. This malware is written in Java, and this malware family is a remote access Trojan, provides access to a victim computer once it's executed on it. But it also steals information, and it sends this information using a C2 protocol between the victim computer and this malware infrastructure. And we're going to figure out a way to detect the STRRAT malware by looking at that connection. Okay, so you probably wonder, you say, why STRRAT? Why didn't you pick something else? Well, STRRAT bubbled up to the top on this chart of one of my favorite malware sandbox providers, any.run. They have this handy chart, the malware trends chart, and when you go in there, they will aggregate the information that's been submitted to their sandbox over time, and the most prevalent families will bubble up to the top. So what I do is I usually start at the top of that chart and start looking at the most prolific malware, and I start looking at the network traffic that they send when that any.run captures when they execute the malware. Now, so what I did is on that malware trends, I noticed that STRRAT was at the top, and then I started looking at submissions, and I found this submission here that when you click in there, there's the network window pane at the bottom, and there's a little spot down there. It says, I think it says PCAP. And when you click on that, you can actually download the network traffic that occurred when this malware sample was executed. You can put that into another free tool called Wireshark, and it looks like this. And there's this TCP port 8219. There's this connection that happens in that PCAP that I'm showing you on your screen. You can see all the different packets that go across the wire at that time. Now, you can actually right click on any of those lines and say, follow TCP stream, and it takes the data, all that ugly stuff that you see down at the bottom, and it basically puts it together in one session for you like this. So once we look at this session, you can start to see some patterns. You see like a number, you see a blank line, you see this really long line, and then you see a number again, a blank line, and then a really long line, and then it just keeps going over and over and over. So to a trained eye, you look at this and you say, oh, well, this looks like messages. It's a series of messages that are sent across the network. And just eyeballing this, I mean, this is the ping command, which I just know because I studied it. It's kind of like a check-in command to STRRAT. So the victim computer every now and then will just check in with the malware infrastructure and say, hey, anything new? Should I be doing anything? And that's the ping command that you see here. Now, just one of those messages, like I said, it's actually several lines. Here we see, the very first one I have this number, this ASCII number. This isn't actually it's written in ASCII on the network. So it's not the actual number on the network. And then it has a blank line, and then it has this big payload. And what we got to do is we got to take this number, which ends up being the length of this payload, in order to chop up this payload. You need that length in order to know when to stop chopping up that payload and when the next message starts. So now that we know that that's the general format of these messages, we can write an analyzer in this language underneath Zeek called Spicy. Now, Zeek will sit there and watch your network for different things that happen that you can say, hey, if the TCP connection is too big, alert me. Or if I'm dropping packets, alert me, that type of thing. Well, what we're going to do is we're going to write a detector that looks for the STRRAT data that goes across the wire. But to do that, we got to write in a lower level language underneath the Zeek called Spicy that actually takes that low level data, chops it up into the fields, and then makes it available to Zeek. Sounds complicated, I know, but it's actually, when I explain it to you, I hope it comes across it's not that complicated. So to get my point across, let's talk about the Zeek, or the Spicy analyzer itself. So here's the Spicy code, and it's only 11 lines. This is a really, I don't want to say trivial, but a very simple protocol that we'll be chopping up. So the real meat of it happens between lines 7 and 11, and this chops up one message. And you can see I'm saying len, L-E-N, that stands shorthand for length. And it's saying you should be looking for data that is an ASCII number, which is exactly what we saw. And this is the cool part. I take that info and I plug it into, or I use a function on it called toInt, and I turn that ASCII representation of a number into a real representation of the number in integer. It's awesome. So now this becomes an integer and I can do stuff with it. And then this field here, I don't really care. I'm not going to save it. I don't care. So I don't name it anything, but I do know that it's the blank line. So I have this series of new lines and carriage returns that are expected from this malware. And then the last line here says, hey, your payload is going to be a size of length. That's it. I mean, that's how simple it is. So this chops up one message. And then if we go up here, we see that one message gets turned into an array. And now we have a plural name of STRRAT messages. So now Spicy's going to look at a connection and parse an array of these messages. Now, how we do that, in Zeek, there's this thing called a dynamic protocol detection signature that you can write. And this is what it looks like for this guy. It's only, actually 2 lines of stuff that you need to search. It's lines 2 and 3. So really what this signature says on line 4 is when you hit these things, enable the STRRAT analyzer that I just showed you earlier. Okay, so when these 2 things are true, turn on the STRRAT analyzer. And those 2 things are, the protocol has to be TCP, so basically throw out everything else. And then this payload has to hit this regular expression. And it starts with an ASCII number, has that new line, and then it's got this command, and then you can see there's the pipe symbol, the STRRAT, and the pipe symbol. And then it looks at it case insensitively. Now, when this hits, it triggers this Spicy program to be running on the connection, which then starts chopping up data and sending it to Zeek. So we can write now a Zeek program, which, don't get discouraged, the first half of this is boilerplate. So we don't really start until line 11. So here in the Zeek code, we're saying on line 11, when there's a STRRAT message parsed and this event fires, we're going to take the data that it parsed. You see here, there's the payload and all that stuff and the connection. We're going to put that into a nice little message. And then we're going to take the payload and we're going to put it in a subfield of the notice log. So if you run Zeek with this logic on the PCAP that I talked to you about earlier, you're going to get a notices log that'll look like this, which really, those 2 lines are the important ones. And you can see over here that it said, hey, I found STRRAT. It says it in the human readable version. And then there is the payload where it starts with ping and all that. Pretty cool, huh? So all that logic detected STRRAT on our network and then gave us the data so we could actually do something with it. Now, to some people, they don't care what the payload is. To a malware analyst, they probably will. There's a lot of tools out there for malware analysts. You can try to decrypt things and, do a complete separate analysis outside of Zeek that you would need this information that Zeek gives you. So even if you're not a malware analyst, you look at this and you're like, why would I want that? There are people that would get this and go, ooh, I got the payload. I know exactly what this malware did. And if it was encrypted, they could try to decrypt it and all that stuff. Now, I'm not going to try to pretend to be an expert in Suricata rules. We've got experts inside Corelight for that. Travis Green, he wrote these Suricata rules, and he took my Zeek logic and basically put it on steroids for Suricata because he not only detected the ping command that we talked about earlier, but he looked for this up and exec command, which is a separate command as well, and wrote a signature for that. And then he also looked for distinct class names in a jar file, which a jar file is a Java file. So because that's got computer instructions in it, we can search it. And when he knew that this particular name shows up in there, and he made a signature for it. He also went into the leaked source code for the malware itself and noticed that there's a license that gets checked, because a lot of times malware authors are not the same people that deploy the malware to the victims. So those people buy the malware from the malware authors, and you got to license it. Well, he keyed in on that check and figured out a signature for that. And then he also keyed in on, I don't want to say it's a reconnaissance check, but when a malware infects a victim, a lot of times it'll check what its IP address is and where it is in the world to just get its bearings straight. And it goes to this website called IP API, and humans could go there and pull their IP information. But this malware does it with something different that humans and other malware don't use. It uses a specific user agent string. And once we see that user agent string going to that domain of ipapi.com, now we know that that's a STRRAT candidate that we're possibly looking at. So what Travis did is he wrote a rule that would actually detect that user agent string going to that website. So one of the very possible things that happens in the wild is malware is created on day one. 6 months go by. Now the security world found out about it. We all went, oh God, we got to write a C2 analyzer for this thing, just like I just showed you, right? So in that gap, in that 6 months, people could have been infected, right? And we don't have a detector that's actively watching the network before that 6 months. But if you have Zeek running and there are Zeek logs historically for you, you can take some of that signature, some of those signature artifacts that Travis put into Suricata rules, and you can actually search your logs historically looking for some of those signature. And another one of our researchers, Simeon, he went in and wrote a SIM search, and specifically what you're seeing on your screen is log scale. But if you're, say, a Splunk user, you can translate this over to your platform of however you search logs. Me personally, I use the find command and I crawl a file system and I look for TSV logs and I search for these things. So whatever your flavor, your tool is, take this meat and plug it in appropriately, okay? And let me put on a screen, this is our just internal log scale example on this PCAP that we're showing you that hit. So if this was a real network and you were running log scale and you were dumping your Zeek logs into it and you ran this query that we gave you, this is a high probability that this could be a STRRAT connection. All right, so with that, I hope you walk away from this and you say, you know what? My network, little more secure against STRRAT, and I have more mechanisms now to detect if STRRAT was on my network. Now at least I can tell what it did, right? I got the log and I got the payloads. If there was anything, I try to keep these videos as short as possible because there's a lot of details in here. I know I skipped some details. I know I did. So if there's anything in here where you go, I totally didn't understand that, just put it in the comments of the video and I'll try to answer it. Anytime anybody asks me questions like this, I try to answer them the best that I can. So if there was anything that was unclear, please do feel free to put down there and I'll try to answer it, and then other people will catch it too. And with that, I hope you enjoyed this, and I hope you come back on, I think Agent Tesla will probably be the next one that I produce for this video. So I hope you come back and check that one out. See you then.